Alright, you guys, let's continue on. We're going to start with the word problems. If we look at number 13, let me zoom out a little bit. Alright, number 13 says we are starting from the top of a tower. So I need to draw a tower. And it says that the angle of depression to a rock on the ground is 54 degrees. So if I have my tower, the rock's going to be along the ground. And the point of view you're looking at is the tower, right? You're from the tower. So I'm picturing that I'm standing on top of the tower looking down to the rock. Well, the angle of depression means it should start from horizontal and go down. So if I draw the horizontal from my point of view and go down to my line of sight to the rock, that's the angle that's going to be 54 degrees. Not only that, but your angle of depression and angle of elevation are identical because they're alternate interior. So I could also say that this angle right here by the rock is 54 degrees. It says that the rock is 135 feet from the base of the tower. Well, here's the rock, and I'm either thinking this side or this side is what I'm looking for, but the base of the tower is at the bottom of the tower. So that means from the bottom of the tower to the rock is 135 feet. How tall is the tower tells me the height of the tower. So X is going to represent how high the tower is or how tall the tower is. All right, so from here we're just going to look at our angle that we can reference. We have an opposite side and adjacent side, so that tells us to use tangent. Remember, tangent is equal to O over A, so if I write tangent of my angle, 54 degrees, is equal to opposite over adjacent, so X over 135. Since X is on top, I'm going to end up multiplying 135 and tangent 54 degrees. And when I type that in, rounded to the nearest hundredth is 2 decimal places, would give me X equals 185.81 feet. Don't forget your units on all your word problems. All right, number 15. The top of a cliff is 85 meters above the sea. Here's my cliff. Says the top of the cliff is 85 meters above the sea. So here's my cliff, here's the sea. The top of the cliff is 85 meters above, which means that the cliff is just 85 meters tall. From the top of the cliff, the angle of depression means we're starting at the horizontal and going down, measures 42 degrees. How far is the boat from the base of the cliff? Well, they haven't really mentioned a boat yet, but I assume that means that the boat is somewhere out here in the sea. And since I'm measuring from the top of the cliff, I'm picturing that I'm up here on top of the cliff, sighting the boat. So angle of depression from my regular line of sight down to the boat is 42 degrees. And remember, that's the same as the angle at the boat. And I have a right angle there. How far is the boat from the base of the cliff? Here's the base of the cliff, here's the boat, so X goes along that bottom side of our triangle. According to my angle, I have opposite and adjacent sides, so this is going to be tangent again. So tangent of my angle, 42 degrees, equals opposite over adjacent. This time X is being divided by, so we're going to flip-flop X and tangent and say that X is 85 over tangent 42. Round to the nearest meter means whole number, which comes out to 94 meters. Don't forget units. Number 17, Genghis Khan flew a kite over the camp of his enemy to determine the distance between his soldiers and the enemy camp. If he let out 880 meters of string and the kite was flying at an angle of elevation of 61 degrees, how far away is his army from the camp? Okay, when you look at this problem, the kite is flying over the camp. So if this is my camp, that's a camp, and the kite is flying over that, well, the string to the kite is going to be where we are, Genghis Khan, away from the enemy's camp. right? And we're trying to find how far away are we from the camp. So if he has 880 meters of string, that's going to be along from my hand to the kite. And it says the kite is flying at an angle of elevation. Remember, angle of elevation starts at the ground and goes up, or some line of sight and goes up. So this would be 61 degrees from the horizontal up to this kite. How far away was his army from the enemy along the ground? So here's his army, here's the enemy. We want to find this side right here. So in relation to our angle, we have the adjacent side and the hypotenuse, which tells me to use cosine of my angle 61 degrees equals A over H, which would be X over 880. Since X is on top, we're going to multiply, so 880 cosine 61 is what we're finding. Rounded to the nearest meter becomes 427 meters. All right, number 19. At a certain time of day, a vertical pole, here's our vertical pole, casts a 5 that's 5 meters tall. So that's going to be here. There's my pole. It's 5 meters tall. It's casting a shadow. The shadow is going to lie on a ground where the 7 meters represents the length of the shadow. What is the angle of elevation of the sun? Well, the sun's somewhere behind our pole so that its angle of elevation with the ground right here from the horizontal up is calculating some degree so that it forms a 7-meter shadow from this 5-meter pole. So when I look, X is my angle of reference. This is an opposite and adjacent side, so we're using tangent. So tangent of X is our angle, equals opposite over adjacent, which would be 5 over 7. Since X on the tangent side, we need to cancel that out by doing second tan of 5 over 7. And this says round to the nearest tenth, so that would come out to be 35.5 degrees because we are looking at the angle. All right, number 21. 21, the Outlook Expressway has a 17% grade. Remember, anytime you see a percent, you need to change it to a fraction as 17 over 100. Grade is really just representing the slope of this highway. So if this is my car, the slope of the highway is 17 over 1. And remember, slope is written as rise over run. So if this is my road, we have a rise of the road and a run of it. This would be the rise, so I would label it as 17. This would be the run, so I would label it as 100. And we want to find the angle of elevation of the road, which is this piece right here. So that's going to be our X. So we have opposite and adjacent. So we'll use tangent of X equals 17 over 100. Since X is on the tangent side, we need to cancel it out by doing second tan of 17 over 100. And this says to round to the nearest degree, which is a whole number, would come out to about 10 degrees. All right, number 23, 25, and 27. Anytime I give you a triangle and I'm asking you to write the trig ratio as a reduced fraction, that means you're just finding the relationship of the sides. So in SOHCAHTOA, you're going to be looking at which function did they give you, which angle am I looking at, in order to determine which ratio I want. Do I want over H, A over H, or O over A? Number 23 is asking for the sine. So sine tells me I need to use the SO function. So my ratio will be opposite side over hypotenuse. B tells me what angle to cover up so that I can figure out what my sides are in relation to it. So B, opposite of B would be 10. Hypotenuse is 26. So this would be 10 over 26. But this is not completely correct. You have to reduce in order to get it right. So I want you to cross through that. 10 divided by 26 reduces to the fraction 5 over 13, so 5 over 13 would be your answer. Number 25 is looking for cosine of b, so now we're going to be using a over h. We're still referencing angle b, so I'm going to cover b up to figure out adjacent side would be 24, hypotenuse would be 26, so 24 over 26 reduces to 12 over 13. So the reduced version is our answer. Number 27 is tangent of b. So now we want O over A from b. So I'm going to cover b up. Opposite of b is 10. Adjacent is 24. So 10 over 24 can be reduced. 10 divided by 24 reduced is going to actually come out to 5 over 12. All right, 29, 31, and 33, this back page, finding the measure of an angle. If your angle was x and I had tangent of x equals 3 over 5, you would undo this because x is location, your variable, is by tangent. So to cancel that out, you would do second tan of 3 over 5, or whatever that function is. If it was cosine, you do second cosine. That's just the idea behind this. The only difference is you have an a instead of an x. Either way, a is still your variable, right? So I'm going to cancel out the variable that's touching cosine. So what I'm going to type in the calculator, sorry, not x, it's a, is going to be second cosine of the fraction or decimal that they gave us. Second cosine of 3 over 5, rounded to the nearest degree, comes out to be about 53.1. The 1 keeps the 3 the same, so this would just be 53 degrees. 31, your variable is still on the tangent side, so to cancel it out, you're going to do second tan of the number they gave you, which is 2.365. So on the calculator, second tan, 2.365, comes out to 67.0, which rounds to 67 degrees. Number 33, this time it's cosine, so we're going to cancel out cosine by saying second cosine of the number they gave us, which is 0.874. Second cosine of 0.874 comes out to 29.0, which rounds to 29 degrees. All right, you guys. Don't forget to check the key online just to double check that you're doing everything right. And if you need to come into tutoring, you are welcome to. Just make sure you're here early and ready to